In this video, we'll take a closer look at representing real numbers on the number line. It's quite easy, you just need a little bit of imagination. You know that real numbers are made up of rational numbers and irrational numbers. And you know that the decimal expansion of rational numbers is either a terminating decimal expansion or non-terminating recurring. And for irrational numbers, it's a non-terminating, non-recurring decimal expansion. So let's see how to represent a real number on the number line using its decimal expansion. So in this example, we are trying to locate a terminating decimal. Let's try to locate the decimal 2.665 on the number line. Okay. So you're looking at a portion of the number line here. You know that 2.665 is going to be in this region. It's going to be between 2 and 3. Okay. Now let's zoom in a bit on that area. 2 and 3. You can break this area into 10 equal divisions. Let's try doing that. This will be 2.1, 2.2, 2.3 and so on up to 2.9. And you know that 2.665 is going to be between 2.6, which is here, and 2.7. So you know that 2.665 is going to be this area here between 2.6 and 2.7. So let's zoom in on that area a little bit. Let's draw it bigger so it's easier to write. So you have 2.6 here and 2.7 here. So if you similarly break this area into 10 equal parts, I'm not that good at drawing, so the parts here are not really equal. So if you break it up into 10 equal parts, it's going to be 2.61, 2.62, 2.63 and so on up to 2.69. And you know that 2.665, it's going to be between 2.66 and 67. So 2.665 is between 2.66 and 2.67. So it's going to be in this area here. Okay. So we need to zoom this small bit again. Let's do that. So you have 2.66 and 2.67. So if you break this up into 10 equal parts again, this will be 2.661, 2.662 and so on. This fifth point is 2.665, 2.666 and so on to 2.669, then finally 2.67. So you find that the point that we need to locate, 2.665, is right here in the middle, and that's how you locate 2.665 on the number line. So this is 2.665. So what we have done here is we have magnified each portion of the number line successively. So first we magnified the area between 2 and 3, and then between 2.6 and 2.7, and finally between 2.66 and 2.67. This process is called process of successive magnification. So just now we visualized a terminating decimal. 2.665 was a terminating decimal. Let's see how to do this for a non-terminating recurring decimal. Let's try to locate a number like 5.37 bar or 5.3777 and so on. So the important thing to note here is that since this is a non-terminating decimal, the process of magnification can go on forever. So you'll never be able to stop because the number here is a non-terminating decimal. So there's no end to the number of sevens here. So what you need to do is you need to decide how accurately you want to locate the decimal, and you will have to stop your magnification process when you reach that level of accuracy. So let's look at how it's done. Let's look at the top here. As we saw in the previous example, to locate 5.37 bar, you know it's between 5 and 6. So you take the area between 5 and 6 and you magnify it. In the next step, you know it's between 5.3 and 5.4. So you go to the area between 5.3 and 5.4 and magnify it. In the next step, you know it's between 5.37 and 5.38. So you go on and magnify that area. So you know that 5.37 bar is going to be somewhere in this part here. So it's going to be between 5.377 and 5.378. So that's what you do in the next step. So you can see that you can continue this process indefinitely because this is a non-terminating decimal. But we need to stop somewhere. So we decide that we only need to locate 5.37 bar up to this level of accuracy. So that's how you do it for non-terminating decimals. the process for locating non-terminating, non-recurring decimals is also the same. The only difference is that instead of having a digit or a group of digits repeating, you'll have non-repeating digits. So let's end this video by restating what we already know. Every real number is represented by a unique point on the number line, and you have seen how to locate that unique point for a terminating decimal and for a non-terminating decimal. In the next video, we are going to look at operations on real numbers. Thanks a lot for watching.